Hello everyone, welcome to another video from C Field Academy where we learn together from each other. So today we'll discuss some of the basic properties of a graph. We'll see what a graph is and what are some of its important properties. So that's why I've labeled this lecture or this video as Graph Basics 1. We also have another video which is Graph Basics 2 where we look at a little bit more advanced properties of a graph. So friends, let's get started. So we will discuss today about different types of graphs. We'll see what a weighted graph is, what an unweighted graph is, what a directed graph and what an undirected graph is, cyclic and acyclicness properties of a graph. Then we'll see what a path is in a graph. We'll see what a connected and a disconnected graph is. Then we'll see what is a tree. We'll also see additional two properties, which is a subgraph or a subset graph and a spanning tree. So let's get started with first weighted and directed concept. So what is a graph? So graph is nothing but a collection of vertices which are connected to each other through a set of edges. So on the right hand side you can see we have actually 4 graphs, and in each graph there are nodes and there are edges. So between each nodes they are connected together through edges. So when we have such a collection of vertices and some certain edges, we call it a graph. Now there could be various options. Let's say edges may have weights, edges may not have weights. So if edges have weights on them, we call it as a weighted graph. So in this case, if you notice, where we have the weight of this edge as 5, another edge as 12. So in the same way, if edges in a graph are labeled with a number or weights, we call it as a weighted graph. And if edges are unlabeled, like in this one, then that graph becomes an unweighted graph. Similarly comes the concept of directedness and undirectedness. So if edges have directions, then the graph is called as a directed graph. Like in this one, you can see there is an directed edge from this node 1 to node 2, and there is also a directed edge from node 3 to node 1. There is also an edge from 2 to 1. So this is an example of a directed graph. Whereas the two graphs on the top, both of them are undirected because edges do not have directions, which actually means you can go from one node to the other and other node to the first one. So there is no restrictions on movement. So as you can see, when we use the concept of weighted and directed, we can have 4 possibilities. We can have undirected and unweighted graph, we can have undirected and weighted graph, can have directed and weighted graphs as well, and directed and unweighted graphs. So similarly comes the concept of cyclic and acyclic. So what is a cyclic graph? So a cyclic graph is a graph wherein certain edges form a cycle. Cycle means we start from a node, we move through a set of edges and we reach the same node again. So on the right side, the graph on the right is a cyclic graph. We can see if we start from node B, we can go from B to C, C to E, E to D, and again D to B. So we reach B in 4 steps without repeating any node, and we are forming a cycle. That's why this graph is a cyclic graph, which means a graph that contains at least one cycle is called a cyclic graph. Whereas the graph on the left hand side, you can see you cannot find a cycle. We can go from B to C, we can go from C to E, but we cannot come back from C to B, or we cannot form cycle in any other way, like E to D, D to B. So that's why there are no cycles on the graph on the left side, and this is why this is called as an acyclic graph. In fact, it's an acyclic directed graph, and the right side is cyclic directed graph. I hope this made the concept a little more clear. Now there are few more examples. Now this one, so this graph has 6 nodes, so we can see the edges have weights, so which means it's a weighted graph. Edges have directions, so it's a weighted directed graph for sure. But let's see if it has a cycle. If we notice, we can go from 0 to 1, 1 to 3, but we cannot return. Similarly, 0 to 1, 1 to 2, but we cannot go further. 0 to 3, then we are stuck. So this graph doesn't contain a cycle. So that's why we can also call this as a directed weighted cyclic graph. Now let's see the next one. Now the next one doesn't have weights, so it's an unweighted graph. It has direction, so it's a directed graph. And notice if it has a cycle. It actually has a cycle. If you notice, there is a cycle from E to D, D to C, and from C to E. So we can also say this is an unweighted, directed and cyclic graph. But in normal sense, yeah, it's an unweighted and directed graph. Now third graph, if you notice, there are no directions, so it's an undirected graph. Weights, it has weights, so it's an undirected weighted graph for sure. Now does it have a cycle? Now this is a question. Now this is, remember, this is an undirected graph. Yes, it has a cycle. In fact, in undirected graphs, we can go in any direction for in the edges. So if we go from A to B, B to C, and then C to A back, we form a cycle. Similarly, we can have a 4 cycle here, D to C, C to F, F to E, and E back from E to D. So even this has a cycle. So it's actually a cyclic graph, an undirected, but it has weights, so weighted graph. Cool. Let's move on. Okay. Next is, what is a path? So path is nothing but a sequence of edges which join a sequence of vertices, of course without repeating them. If we repeat them, then it becomes a walk, but walk is a little advanced concept, so let's not confuse for now. Let's just see path, which is a set of vertices, set of edges that joins a set of vertices. In this case, I have given an example. A path is from B to A, A to C, and C to E. Remember, all these edges and vertices have to be adjacent and non-repeating. So what is a connected graph? Next comes the concept of connected graph. So we say a graph is connected if there is a path between every pair of vertices. So you pick any 2 vertices, there should be a path between them. In this case, there are actually multiple paths from FE, F to E, and E to D. There is also another path from F to C and C to D. So a connected graph is a graph where you pick any 2 vertices, there should be at least one path. In fact, a connected graph always has one connected component, which means if you notice the graph from an aerial view, you would see that you cannot break the graph into multiple components or 2 components. Now similarly, the concept of disconnected graph. A disconnected graph is a graph where doesn't exist a path between every pair of vertices, which means there is possible that there are 2 vertices which are not connected to each other through a path. Now here is an example, a disconnected graph. Let's take vertex J, let's take vertex A. If you notice, there is no path between them. Why? Because the graph is already disconnected into 2 parts, and at max I can reach from A to C, C to G, but I cannot reach J. So that's why this graph actually has 2 components. And it's a disconnected graph. Now next is the concept of tree. So tree, as per definition, is a connected graph, 1, is an acyclic graph, 2, and it's also an undirected graph. We may have directed trees as well, but normally we don't consider it. So it's a connected graph, it doesn't have a cycle, and it's undirected graph. There is also in other way, it means if we take any two vertices in a tree, we'll always have exactly one path, because if we have multiple paths to reach two vertices, then it actually forms a cycle. So as per our definition, there is only a single path between any two vertices. You pick any two vertices, there is only a single path. In this case, vertex 2 and 6, the path is from 6 to 5, 5 to 4, and 4 to 2. Similarly, and there are no cycles. So when we say a graph, we normally mean an undirected, unweighted graph. Now let's look at what a subgraph and a spanning tree is. So subgraph, as its name suggests, it is a sub of a graph, which means it's a subset of the original graph in such a way that its vertices and edges are subset of the original graph. So if we take this graph on the left, which has 6 vertices, you can see if we choose A, B, C, if we choose vertex A, vertex B, vertex C, which is the subset of the original vertices, and we choose the related edges, we will get a graph that is a subgraph. So in other words, ABC is a subgraph. ABC is a subgraph of the original graph. So remember, if we choose the number of vertices, we have to select all the corresponding edges that are connected to the vertices. Now let's come to the concept of spanning tree. As the name suggests, it's a tree, so which means it will not have a cycle. So spanning tree is nothing but a subgraph which is a tree, and it includes all the vertices of the graph. So you can see the graph on the right side, which has 6 vertices, and we have highlighted a tree A, B, A, C, C, D, C, F, and F, E. So this is a tree. Notice it doesn't have a cycle, and it is a subgraph of the original graph. Remember, we are not taking the edge BC into consideration, because then it will not form a tree. So it's a subgraph which is a tree, and it connects to all the vertices. It doesn't leave any vertices. So that is a spanning tree. Okay, let's move ahead. So as we end this session, I'll leave you with this question. So there is a graph shown here which is a 5 node graph, or 5 vertices and 4 edges. So I'll leave it to you to decide or discuss whether it's a connected or a disconnected graph, if it's a weighted or an unweighted graph, is it cyclic or acyclic, is it directed or undirected, is it a tree? So make sure to post your comments. If you want, you can also email me if you want a solution for this. If there are any questions as well, post as a response to this video. Alright guys, thanks for being with me in this video. I would suggest you to definitely look at other videos on our channel, and like and subscribe the channel as well. Thank you so much, and see you again in the next video.